Now, we've been working with derivatives now moving forward. As we've talked about on Monday, this is all based on that, limit definition of derivative, but we want to use rules because it's a little bit easier to work with moving forward if we just have the rules instead of having to do a limit every single time. Okay, so the power rule was something we looked at. Derivative of constant terms is definitely something we looked at. And this is us branching forward, right? What happens when I can't use those in the limit properties? Well, hey, the product rule was the one that I introduced at the end of class on Wednesday. Okay. Now, with that said, make sure you see here, if you wanted to, you can rewrite this function as 3x squared times x to the 1/2, which simplifying is x to the 5/2. All right, we didn't have to use a product rule here, so there are other ways to deal with this. So when you look at the derivative here, then we could have just used the power rule. The reason I show this is, hey, we better get the same thing as what we're going to find here. When I go use the product rule, I better get back the same result. 15/2 x to the 3/2. Okay. Everyone follow me there? Just kind of how we can simplify and use the product rule. I mean, the power rule, sorry. An important note to make sure that you definitely see is, where did I get this from? Anytime we see a radical, that's a rational exponent, right? Make sure that's definitely one thing we want to be comfortable with. Be careful also to see I needed a common denominator to add that. So I made that 2 instead of 2, I used 4/2. That's where the 5/2 came from. Okay, so just little things, don't make sure you don't overlook. But when we do our work here, it may not look exactly like this, but we should be expecting something equivalent to 15/2 x to the 3/2. Okay. So let's go work that out. Now, as far as dealing with this is concerned, the place that I recommend anytime we're dealing with the product rule, we're going to look at the quotient rule as well today. What I recommend is make sure you remember, hey, I'm going to need the derivative of both of the factors separately. So let's go look at the derivative of the 3x squared as well as the derivative of the square root of x separately. Okay. Now, with that in place, would we agree with 6x on the first one? Any concerns where that's coming from? Now be careful, the second one then, this is where again a rational exponent is going to help us out. So this will be 1/2 x to the negative, 1/2. Remember, they were subtracting by 1, so 1/2 minus 1 is why we're going to a negative now. All right, now make sure you see here what we found over here. This is the derivative of each of these separately, is what we found here. Okay. When we deal with the derivative of this from the product rules perspective, we're going to say, hey, this is the first factor. This is the second factor. So the derivative of the product rule says, hey, let's do the first factor times the derivative of the second factor. Keep in mind, we already did it, so you don't necessarily have to write it this way. Plus the second factor times the derivative of the first factor. With that in place, we have 3x squared times 1/2 x to the negative 1/2 plus x to the 1/2 times 6x. That makes you see I changed that other radical because we're going to have to do some simplification here. So might as well just convert it over while we're dealing with it. From this first one, we'll get 3/2, but make sure you see here, we're going to have 2 minus 1/2. And the other one's going to be 1/2 plus 1. Using that same kind of common denominator thing, make sure you see here, both of those will end up giving us 3 halves. So if you take 2 and you subtract a half from it, hey, I have 3 halves. If you take 1 and you add a half to it, we have 3 halves. Is everyone good with the 3 halves here and the 6 here, though? Out front. What can we do with this, though, now? We can bring it together because they both have x to the 3 halves, right? Does everyone see that? That's not always going to happen. Keep in mind, we didn't even need to do the product rule here with this one, okay? So understand that's why we're able to now. It's because I could have used the power rule after some simplifying, okay? With that said, though, make sure, again, we're going to need a common denominator here. So 6 becomes 12 over 2, which 12 over 2 plus 3 over 2 gives us 15 over 2 x to the 3 halves. Which if we look back, guess what? That's exactly what we had earlier. Hopefully what you see, the power rule is definitely more straightforward, okay? But this definitely is something we need to be comfortable with as well. There will be problems that, like on a test, I could say, hey, use the power rule to differentiate this, okay? Or I could just tell you to find a derivative and you have the freedom to choose the method. So keep that in mind. Any questions with this one I can help someone with? Do we feel okay with both ways, whether you simplify and use the power rule like we did here first, or using the product rule? Well, here's another one then. One thing you're going to find with some of the functions we work with, we have different ways we can handle it, okay? So please understand that there are different ways to handle how we differentiate something. For this one, we're writing something down that has a fraction. We talked about the product rule, but we have not talked about a quotient rule yet. So we're not going to be able to do that yet until we look at it, right? But there is a way to use a product rule here. Now, if I remember right, didn't we do this one the other day with a different approach? Let's go back and look. That's in the other thing. 1 second. Let's pull it back up. Hopefully I didn't change it. So this was one of the ones that I used last week when we were just introducing the fact that, hey, we have the limit definition, but we can use patterns to help us move forward. Okay. But make sure you see here that just because I have division doesn't mean I have to use a product rule or a quotient rule. Since it's just x squared in the denominator, remember, this was the first approach that we looked at, how I can break it, what we call, breaking up the fraction into 3 fractions rather than 1. Just make sure you see, once you simplify, you can use the power rule. Everybody kind of remember looking at this one last week? Well, guess what? Instead of using the power rule, let's go do the product rule instead this time, okay? One of the things, though, we want to make sure to look at here, we should get 2, oh, what is going on, y'all? We should get 2 minus 10 over x cubed, or x with a negative 3 exponent. Everyone follow me on that? What we're expecting to see here? Now, with that said, then the way that we can handle this from a product rules perspective is to say, hey, I can rewrite this as x to the negative 2 as an exponent. What is going on? Times 2x cubed minus 3x squared plus 5. But what did I put around the numerator? What did I put around this statement to make sure to show I'm parentheses, right? So I didn't get rid of the fraction. We just rewrote it. Everyone follow me on that? Instead of having this in the denominator, I'm bringing it up, but to do that, we need a negative exponent. Okay. What you'll see from here, if you wanted to, you could distribute this, and that would give us what we found before. So we're not going to do the same thing that we did last week. This time, we're going to do the product rule. So let's go look at each of these separately now. What is the derivative of x to the negative 2? And then what is the derivative of this 2x cubed minus 3x squared plus 5? So what did somebody get though when they differentiate this one? What's your exponent? -3. Very good. Does everyone agree with that? Bring down the exponent, but remember subtracting 1, right? So -2 becomes -3 when you subtract 1. Very good. Now, with that said, this other one we have to be careful because now I have multiple terms, right? But remember, if you need to rewrite it like we saw here, if you need to rewrite it this way, nothing's wrong with that. Please hear me out. Why is it doing this, y'all? So here we have multiple terms, right? If you need to show yourself that, hey, I'm doing the derivative of each of those individually, that is fine. There's nothing wrong with that. So if you need that extra step on this problem, make sure you go through and do that. But just as we did this term here, we can just go through and do each one individually. Would we be comfortable then if I came to this first term and said 6x squared? Where does the 6 come from? And the 3 was the existing exponent, right? And the squared part, hey, I subtracted 1 away. This next one would be minus 6x. What goes after that, though? That's it, right? Because a derivative of that constant value here, that goes to 0. Okay. We all good with that? Now, when it comes to like practicing your homework and stuff, right, and get ready for tests, always pick the one that you feel is going to be the most straightforward for you. Okay. I think what we did last week is definitely the best way to handle this problem. I'm using this for a teaching point to show that, hey, this is how we use the product rule moving forward. Okay. Also note this is helping me set up the quotient rule. This is going to help me with the quotient rule. Okay. With that said, then to differentiate this, what goes first? What do you mean? How do we build the product rule? All right, so first times the derivative of the second. Okay, so we're going to say, hey, x to the -2 times 6x squared minus 6x. I took the first factor and I multiplied it with the derivative of the second factor. Okay. What goes behind that? Plus the second factor times the derivative of the first factor. So make sure you see as again as we go through this is first times the derivative of the second plus second times the derivative of the first. That's what we're building there when we go through that. So the second factor in both of these, make sure you see it's a derivative of something. Whereas the first factors in both of them, it came directly from the problem. With that said, for the product rule, what do we always put in between them? A plus sign, right? That's definitely one of the things we don't want to forget. Well, hopefully what you'll see from here though is I'm just going to go into the distribution now. So distribute the x squared and distribute the -2x cubed. What stands out to someone though after I do the distribution there? We're going to combine my turn. Right, well, yeah, one of them cancels out though, right? That's not always gonna happen, but again, we kind of saw that one of those things that we should cancel out from the previous problem, right? So make sure you see here that like, hey, that's kind of nice. Those are gone. All right. So after I do that, combining like terms, I'll have 6 - 4, and then I just need to keep the -10 x to -3. Now, one of the things that you definitely have to make sure you're going through, if the homework's not going to be enough for you to practice and learn this, but you need to practice and learn these rules, right? We're going to have a product rule, we're going to have a quotient rule, and we're also going to have something called the chain rule, because as we look at this, what you're getting into is the fact that, hey, we're looking at stuff we talked about in algebra. FG of X, right? We're dealing with that idea. I just multiply two functions together to make a new function, right? The next step that we're going to look at is what happens when I try to deal with that division. All right, some different ways. Adding and subtracting, that just makes terms most of the time, right? So that would just kind of go through each term. We've kind of dealt with that already. The other thing that we have to work with, does anybody remember what this means when we do the f of g of x statement here? Y'all remember that one from college algebra?
F multiplied.
Not multiplication.
Multiplied.
This is multiplication. So that can't be, huh? Composites, right? That's where, hey, if this is multiplication, this is saying plug one function into another. So that will be the three situations that we have to talk about as we deal with derivatives, because those will come up as we work with them, okay? Any questions with this one though, using the product rule to work it out?
How did you? Yeah.
This is the equation we were given,
Okay.
right? What did I move?
X.
Just this piece, right? But if I move from the denominator out of the denominator, what did I change about it?
This.
I just made a negative exponent, right? So just remember negative exponents, like if I wanted to, I could rewrite the final answer here that we found for the derivative as 2 - 10 over x cubed. Okay. So I was showing that if you use the negative exponent, then we could just use the product rule to differentiate. Okay.
Usually, it doesn't really matter what approach you take.
Well, like I said, this would be the much more straightforward approach here to do. Go ahead and simplify it since it was just x squared in the denominator. And what you'll see is differentiating that is a lot nicer than what we just did. Because hopefully what we're seeing is we did this, all this extra stuff last week for the sake of walking through it, right? But technically speaking, what we're talking about now, what I hope that we can get to is that we can see that that's all we need. That, hey, that 3 that was in there, derivative of 3 is 0. The derivative of 2x is just 2. And then when I get to that 5x and -2, right, I can bring it down. So this to me would be like, I'd rather do it this way. Okay. Now there, as I mentioned, though, always read the directions when it comes to like a test or something with what is expected. Everyone clear on that though? Any concerns with this one I can further clear for somebody? All right, well, as mentioned, then if we can do this, the product rule, we need to jump into what is the quotient rule. So let's go through that with the same problem. Okay. The good news is for the quotient rule, we can go over here and copy some of the stuff that we've already done. There's no need to redo this whole problem. So it's just kind of below what you were doing in your notes. I would just say, hey, this is now going to be the quotient rule. What you'll see here, though, they use n of x and d of x to say numerator, denominator. Okay. Now, as far as getting the derivative, as you can see here, we're going to keep it as a fraction now, and we're going to go through these steps. What I hope that you see, though, is that the numerator is not completely different from what we just looked at, where we're going to take one thing and multiply it with another. All right. So the numerator looks similar to what we just did. However, what is in between the two terms? Subtraction, right? And that comes from negative exponents. Understand that, hey, I have subtractions. At some point, I'm going to have a negative exponent I'm dealing with, okay? A way to remember this, though, instead of using d of x and n of x, is just to say, hey, when I deal with this, I can say low d high. So this is low times that d high minus high d low all over low squared. So low d high minus high d low all over low squared. I'm sure you could find a song on YouTube to listen to and help you remember it if you need that. But this is definitely another formula that we have to have memorized. The only difference here is instead of saying first times the derivative of the second and through all that, what we're doing is making it focused on the denominator and the numerator. Make sure you see, though, the first thing that has to be used, though, is the denominator. So low, d high, and then subtract high, d low. The order of that matters now. With the product rule, you could have flipped the order all you want because it was addition. But because it's subtraction, we have to keep the order the way it is. Everyone's following me so far? Now with that, we have our derivatives already, so let's go build the quotient rule. Now keep in mind, we're looking for that 2 minus 10 over, or 2 minus 10, x to the negative 3. It's not going to look the same, but that's what we're trying to get to. Okay. With that said, remember at this point, we're going to take the denominator first. So it's low times the derivative of the high, the numerator. Similar to what we just did, right? But the big difference is I no longer have a negative exponent. That's the part we have to be careful of. Instead of x and negative 2, it's x squared. So be careful there. Minus, now we're going to do high, the numerator, times the derivative of the, oh, I should definitely change this, y'all. I'm saying all that, but I have x to negative 2 here still. We have to make that adjustment. I'm sorry, y'all. I'm going too fast. Slowing down. So when I was back here, when I copied this over, I should have said, hey, now we're focusing at it from the fraction perspective. So instead of that, we should be using this for the denominator. Remember, follow me on that change? So when I get over here, that's going to have a big impact on this piece here. Now it's just 2x. Makes the derivative a little bit nicer, actually, from that perspective. What is it all over, though? Right? The denominator itself, whatever it is, square it again, right? What do we have to do now? Simplify. What do we have at this point once we write this out? Oops. But like this right here represents what? That is the derivative, right? Is it in a nice form? Not necessarily, but please understand that is the derivative, right? So once you write that out, hey, I've gotten the thing I was trying to find from here. I'm just simplifying. If this was a single problem on test and I said differentiate this and you chose a quotient rule, I'd probably take off 2 points if you stop here out of 5 because you got what was needed. Everything after this is just simplifying. I might even justify 1.5 on some of them, depending on how much is going on. Like say I throw a square root in there, right? That's going to be a little bit more involved from a simplifying perspective. Okay. Just make sure you see here, I don't have as many negative exponents involved. So the simplifying is not as bad as the other one. Nice thing though is again, after we distribute, what can we do? Oh, be careful. Let me slow down. Let me slow down. I messed up one of my signs. Okay. Make sure you see here, I distributed a 2x to all of these, right? But we're subtracting. So as I distributed my 2x, I should have changed all three signs, not just the first and last one. Okay. So make sure you have a note to yourself that like, hey, distribute 2 and deal with the negative. If you need to write it separately, go ahead and do that. But I changed my sign because what should these two terms do right now? And just like we saw before, those are gone. So we have 2x to the fourth minus 10x all over x to the fourth. Does this mean we got something completely different? Uh-oh. Completely different than what it was supposed to be, though? Is this the same thing that we found earlier? Huh? Well, understand this, you could stop here. It is the same thing, though. Please understand this, stop here. There's no need to go further. If you want to connect it back to the other one, though, then you could go over here and say, let's break up this into two fractions rather than one big fraction. Once you do this, that would give us the same thing. Okay. What I will say, when you do quotient rule, if you're choosing to do the quotient rule, stop here. There's no need to go further. Right? When we talk about dealing with graphs like this, we can make justifications for both of these situations being helpful. Okay. The way we chose to solve all the other way, that's what gave it to us in this one. I know I made a couple mistakes there. Is there anything I could clear up for somebody? So hopefully what you see here, we have 4 focuses that we've kind of made so far. Power rule, well, I guess it's 5. I don't really say, but power rule, dealing with the derivative of constant, right? The sum and difference rules is kind of mixed in there. I know the software might talk about the sum and difference, but remember I kind of pointed that to the limit properties of going through each term as we do a derivative, okay? Then we had the product rule and the quotient rule. And we need to be comfortable with all of those as we go into different situations. Because as we set the foundation, now we're going to start getting to move into some application problems. So that bonus problem I put on the test, know that that's actually going to be some problems on your next test. Okay. With that, let's go look at these two functions real quick. If I give you these functions, differentiate them for me. All right, so what does someone get for the derivative of the first function here? When we write out f prime of x. All right, so before we do the derivative, yes, you could have also wrote it that way. That's correct. All right, so what is the derivative of that then? What's derivative of 3, y'all? 0, that's gone, right? So how do we handle x to the 1/2 when we're trying to differentiate it?
It's
Right? Now, keep in mind, the only difference here is it was subtraction, so it'd be a negative 1/2, x to the negative 1/2. Not because of the derivative, but because it was 3 minus the square root of x, right? So be careful there. Excuse me. We good with that? What y'all get for the derivative of g?
Two.
That was a little bit nicer. Any concerns there with getting those? All right. Well, with that in mind, let's copy over our derivatives and apply this to what we just talked about. Okay. So understand I can give us individual functions. We need to be able to get the derivative of them. Okay. What if I ask us then to go find a new function? Where I want to use this new function, alpha of x, by doing what with my two functions? Multiply them together, right? So understand here, I'm calling it alpha of x because it's a new function, but this new function, alpha of x is going to be equal to f of x times g of x. Okay. It's really important that we pay attention to how function notation can be used, because in our course, we're going to start seeing stuff like that. If you looked at that bonus problem on the first test, it talked about finding the profit function, but I didn't give you a profit function. I gave you a revenue and cost function. So if you know your revenue and your cost, what should you do to get the profit? This is one thing that I thought more people would get at least 1 point from that bonus problem. If you have revenue and cost, how do you bring them together to get profit? Revenue minus cost. If you know how much money you're bringing in, how much it costs you to do that, subtraction will tell you what money you've earned. Now that's a simplified thing, right? Because if you're running a business, there's more to it. But oftentimes what you'll find is you'll put all your revenue into one function, all your costs into one function, even though they all might have their own thing built into it. Like cost could be taxes, dealing with leasing or different kind of things depending on what you're trying to do. Okay, so keep that in mind. So for some reason, sometimes you might need to multiply two functions. Okay, so be prepared to see it in this form. Now for us here, if I'm trying to differentiate this function here, we got f and g already because that's what I did on the previous problem. Make sure you see here, this sets us up to use what? The product rule, right? Now, if you want to, you can go multiply that out, deal with rational exponents. Please keep that in mind. But that's a lot of work to go through and multiply that out when their derivative sometimes might not be as bad as they seem. Okay, so let's go into the product rule. So if you wanted to find the derivative of alpha of x here, right? What does the product rule tell us to do? All right, good. So we're going to take that first function, 3 minus the square root of x. You said times the derivative of the next one, right? So we're all good there. Where am I getting that from? What comes next? Plus sign, very good. X squared plus 5 times the negative 1/2, x and negative 1/2. Hopefully what you see, and I kind of build it the same way I did the previous one. We'll go get my derivatives first, and then let's fill in as I need. At that point, we have our derivative function of alpha. That is the derivative function. So all we can do now moving forward is the simplifying perspective. Oops. I'm going through the rational exponents a little bit quicker because we did them earlier. But make sure you see here, when I do this multiplication, I had half of an x plus a whole x there as far as the exponents are concerned. So that's where I'm getting 3/2 from. When I do this one here, it's 2 minus a half. So again, that's where I'm getting the 3/2 from. Okay. The only other thing we can do here then is combine like terms. Now, is every function gonna have rational exponents in it, y'all? No, please keep that in mind. I'm making sure to practice it in class though, so we can at least see it and not be something that you get stuck on a homework assignment, okay? Know that this is definitely something to be ready for on a test as far as dealing with radicals involved, okay? I can use square roots, cube roots, and all of that. As far as simplifying this one though, we would have six x minus, sorry, minus 5/2 x to the 3/2 minus 5/2 x to the -1/2. One thing I would double check, like as I look through my work right now, is that like, hey, this was a -1/2. I'm supposed to have negatives on both of those. Okay, that's definitely something to watch for. As you saw in my previous problem, I had to double check because I didn't distribute the negative properly on the quotient rule. Now, what I hope you see here, this is about making sure we know how to get the derivative of an individual function. And then we need to know the product rule and how to put those together to get a new derivative. Okay? So definitely needs a product rule. Now, as far as time for today, we don't necessarily have more time to do more, but guess what I had next? All right, so this would be something I would encourage you if you want to do on your own. Go try to find the derivative of the quotient of both of those. F divided by g of x. All right. Now, are there any questions though with the product rule before we finish up today here with this one? One area where all I can say is practice. You have to practice. Practice some more. The homework assignments may not be enough practice. That's where I would encourage you to go to a textbook or something and look at it more. I don't remember if I shared it or not on our page. If you want an open stacks textbook instead of having to go through Pearson all the time, let me know. I think I had one on my open math. Double check while I'm saying that. Yeah, they have a PDF document for a free textbook that it's going to be on a PDF form though that you can look at. Okay, so if that's something that will benefit you, just let me know. I can get it onto our Canvas page for us. See if I already did it for my online class. Yeah, I already did it in my online class, so I could just copy it over. Is there any questions about the stuff we've covered today that I can help someone feel better about? All right, so that's all we have time for today. Before you head out, come see me up here at the front so we can get the test handed back.